Well, hello. It looks like Kristen and Cassidy are here. Hopefully the rest will join us or watch the recording, but it's good to see you. We're going to do some more work on proving identities this afternoon and take a look at the sum and difference identities for sine and cosine. But let's do a quick review of the kinds of problems we did on Monday. So I want to prove this. So my advice is to start with one side. So I'm going to say left-hand side equals. We're going to have a string of equations to get it to equal the right-hand side. So I'll say left-hand side is tan theta minus cotan theta divided by sine theta cos theta. Now that looks pretty nasty. So what I like to do in this situation is to turn everything into sines and cosines. So what I think I will do is I will rewrite this as tangent theta is sine theta over cosine theta minus cotangent theta is cosine theta over sine theta, all divided by sine theta cos theta. So how do we do this? Hello, Mr. Hickson. Welcome to our group. What I'm going to do next then is I'm going to simplify this numerator. Remember, how do we add fractions? This times this minus this times this over this times this. So what we're going to get is sine theta times sine squared theta, minus cos theta, cos squared theta, all over sine theta, cos theta, all divided by sine theta, cos theta. So what does that mean? I've got a fraction divided by a fraction. So let's go ahead and write it using that division. Divided by sine theta cos theta over 1. So we know how we have to do division. We have to invert and multiply. So this will equal sine squared theta minus cos squared theta over sine theta cos theta times 1 over sine theta cos theta. And then what do I have? Then I'm going to have what? Downstairs, I get sine times sine squared theta. Cos times cos squared theta. Then I have sine squared theta minus cos squared theta times 1. So that, of course, is just sine squared theta minus cos squared theta. Now, look at what we're trying to get to. We are trying to get to this secant squared theta minus cosec squared theta. Am I getting close? Well, let's take a look. Let's see how this is going to go. So I have a common denominator, this whole thing divided by that. So I can rewrite this as sine squared theta over all that stuff, over sine squared theta cos squared theta, minus cos squared theta over sine squared theta cos squared theta. And look at what happens. We get some nice things to happen. Sine squared over sine squared divides out. So that's 1 over cos squared theta. Minus, now the cos squareds divide out, and I get 1 over sine squared theta. 1 over cos squared theta is secant squared theta. So equals secant squared theta minus 1 over sine squared theta is cosecant squared theta. And that's what we wanted. That was our right-hand side. So if you go all the way back to the beginning, that was our goal. I wanted to get the left-hand side to be secant squared theta minus cosec squared theta. So that is my right-hand side. And that's done correctly. So you see the process. Left-hand side equals right-hand side. That's the strategy I want you to use when you are doing problems this way. All right. Now today we're going to add a couple identities to our list, namely the sum and difference identities. So let's quickly establish those and then do a few problems with them. So we have cos of A plus B is cos A cos B minus sine A sine B. So what is this good for? Well, one thing we could use it for would be to do something like cosine of 75 degrees would be cos of 45 plus 30. Cos of 45 degrees plus 30 degrees. So if that's the case, 45 degrees is going to stand in for A, and 30 degrees is going to stand in for B. So I get cos A, cos B, cos 45, cos 30. Cos 45 degrees, cos 30 degrees. Minus sine A, sine 45, sine 30. So how is that going to work? Over 2. Minus sine of 45, which is root 2 over 2. Sine of 30 degrees is a half. So I wind up with root 6 over 4 minus root 2 over 4, which would be root 6 minus root 2 over 4. So that's one use we have for the cosine A plus B identity. Cos of A plus B, cos A cos B minus sine A sine B. So you'll notice the SIGN changes. It's plus here and it's minus here. So if I do the similar identity, if I would take cos of A minus B, cosine of A minus B, the rule for that is cos A cos B plus sine A sine B. Cos A cos B plus sine A sine B. So this time let me go ahead and do cosine of 15 degrees, which I will think of cos 45 minus 30 this time. Cos of 45 degrees minus 30 degrees. So in that case, 45 degrees stands in for A, and 30 degrees stands in for B. So using that, cos A is cos 45, cos B, cos 30, plus sine A, sine 45, sine B, sine 30. Cos of 45, root 2 over 2. Cos of 30 is sine of 60 is root 3 over 2. Sounds familiar, doesn't it? Sine of 45, root 2 over 2, sine of 30, 1/2. So we get root 6 over 4 plus root 2 over 4, which is root 6, plus root 2 over 4, for the cosine of 15 degrees. So we have this identity, cos of A plus B. We have this identity, cos of A minus B. And of course, we also have a similar pair of identities for sine. We'll take a look at sine of A plus B, and we'll look at sine of A minus B. So let's add those to our list. What is sine of A plus B? Sine of A plus B is sine A cos B plus cos A sine B. And notice the sines, the SIGNs are the same. For cosine, they flipped. For sine, they stay the same. Sine of A minus B is going to be what? Is going to be sine A cos B minus cos A sine B. So let me ask you to use this to come up with the following. So use this rule to find the sine of 105 degrees. So use one of those identities to make it work. Hello, Harley, I'm glad you're here. So see what you can do with that one. When you have an answer, do your best to post it in the comments and I will take a look at it. So when you get an answer again, please post it in comments. If you need a hint, 105 is 60 plus 45. We have an answer. 60 degrees here is standing for A. 45 degrees is standing for B. So I have sine of A plus B. I'm using this version. Sine A cos B. So sine 60 degrees cos 45 degrees plus cos A cos 60 sine 45 degrees. So let's see if Kristen's number is correct. Sine of 60 is root 3 over 2. Cos of 45 is root 2 over 2. Plus cos of 60 is the same as sine of 30, which is a half. Sine of 45 is root 2 over 2. So I get root 6 over 4 plus root 2 over 4. So yeah, it looks like Kristen's answer looks pretty good. So that's a strategy that we can use to work on some more exact answers for additional angles that we can get by adding or subtracting angles we already know. Let me ask you to do the following, please. Can you use these rules? You've got formulas for sine and cosine, and if you want me to give you the formula for cosine again, I'll do. Cosine of A minus B is cos A cos B, cos A cos B, plus sine A sine B. Kristen's numbers are different because she just did the ordering different, but certainly root 6 over 4 plus root 2 over 4 is the same as root 2 over 4 plus root 6 over 4. Order certainly doesn't matter there. Cos A cos B plus sine A sine B. This is what I would like you to do. What is the cosine of pi over 2 minus theta? So I'd like you to use this formula, if you would please, to figure out what cosine of pi over 2 minus theta is. When you get your answer, post that one on the comments. I'll take a look at it. Who has an answer for me? Who's brave? We have an answer. Let's see if that's right. So pi over 2 is going to stand for A. Theta is going to stand for B. So what I get is cos A, cos pi over 2, cos B, cos theta, plus sine A, sine pi over 2, sine B, sine theta. Cosine of pi over 2, remember, let's look at our picture. Pi over 2 is here, so the x value is 0 at that point. Cos of pi over 2 is 0 times cos theta. The y value, remember this is the point 0, 1. So sine of pi over 2 is 1 plus 1 times sine theta. And that answer is sine theta. But I argue you should have known that before doing the problem. Pi over 2 minus theta, 90 minus theta. If theta is 20, 90 minus theta is 70. Those angles are complementary. Cosine means sine of the complement. Pi over 2 minus theta is the complement of theta. So we can sort of get that directly if we understand how that works. So just to remind you of that, so complement rules, which in essence we just proved. So let's talk about it. So the cosine of 20 degrees is the same as the sine of 70 degrees. The tangent of 10 degrees is the cotangent of 80 degrees. The secant of 50 degrees is the cosecant of 40 degrees. Cosecant, secant of the complement. Cotangent, tangent of the complement. Cosine, sine of the complement. So all of those properties work that way. So the sine of pi over 2 minus theta is the cosine of theta. Similarly, the cosine of pi over 2 minus theta is the sine of theta. And those can be proven like we just did looking at the sum identities for sine and cosine. All right, let's look at some proofs. And for the most part, these proofs are a little easier to get that to happen. Daniel says, I don't know how to do it. So we'll take one more look at it. What do we have? This is what we have. Cosine of A minus B is cos A cos B plus sine A sine B. So A is pi over 2. B is theta. Cos A is cos pi over 2 because A is pi over 2. Cos B is cos theta. Sine A sine pi over 2. Sine B sine theta. Cos pi over 2 is 0. So 0 times cos theta sine pi over 2 is 1. 1 times sine theta. That gives us sine theta, which proves what? What does that prove for us? It proves that the cosine of pi over 2 minus theta is sine theta. So, I mean, the biggest challenge I have in terms of doing these video lectures is I have difficulty assessing your work. So it's harder for me to see where you're struggling. So I do appreciate Daniel for stepping up and saying that so that I can address those issues as they come up. All right, let's do an identity. Let's try this one. So we'll take sine of A plus B, prove. Sine of A plus B over cos A cos B equals tangent A plus tangent B. So our process, what do? We start with one side, more often than not the left side. That tends to be the more complicated side. It certainly is here. Left-hand side and a string of equal signs to see if we can get it equal to the right-hand side. So I have left-hand side is sine of A plus B over cos A cos B equals. Now, we have to use the sine of A plus B identity. That's sine cos plus cos sine. So sine A cos B. With the sine function sin, the sign stays the same. Sine A cos B plus cos A sine B. All divided by cos A cos B. Now, what's our process? I have a single denominator. In the case of having a single denominator, I'm going to break it up. The top over the first guy over the denominator plus the second guy over the denominator. So what does that become? Equals sine A cos B over cos A cos B. Plus cos A sine B over cos A cos B. Equals what? What cancels? You'll notice cos B over cos B divides out, leaving me sine A over cos A. Plus, notice here the cos A's divide out, and I get sine B over cos B. But sine A over cos A, that is just tangent A. Plus sine B over cosine B, that's just tangent B, and that equals right-hand side. So again, notice my process. Left-hand side equals this, which equals this, which equals this, which equals this, which equals that, which is the right-hand side. That is the process that I would like you to do. Right, let's try one more of these in the same kind of vein. This time I'm going to let you try it first, give you a few minutes, and then I will make an effort to take a look at it. So try this one, which I think should be doable. Should be a little bit easier than some of the others. Cosine of A plus B over cos A cos B. Equals 1 minus tan A tan B. All right, try that one. We'll take a look at it together shortly. Well, hopefully you've had a chance to work on it. Let me jump in. Start left-hand side equals cosine A plus B over cos A cos B. Cos A plus B, cos cos minus sine sine. Cos A cos B minus sine A sine B. All over cos A cos B. So I have a situation again where I have a common denominator, so I'm going to break up the numerator each over the denominator. So that's going to equal cos A cos B over cos A cos B minus sine A sine B over cos A cos B. And look at what I have here. Cos A over cos A would divide out. Cos B over cos B divides out. 1 times 1 over 1 times 1, 1 minus. Then let me rewrite this guy as sine A over cos A. So you'll notice fraction skills really come in handy here. Sine B over cos B. What does that give me? That gives me 1 minus tangent A tangent B, which equals the right-hand side. And I am done. So you get a problem like that on a test, you should be pretty happy because it's relatively straightforward. As long as you work through the identity, it shouldn't cause too much trouble. Now, they can get a whole lot harder, but in light of our circumstances, I think I'm going to stick with the more straightforward ones. Okay, what I want to do next is I want to go back and look at sine of A plus B and cos of A plus B so that you can generate two identities for me. Okay, so here we go. Here's the two that we're working on so far this afternoon. Sine of A plus B is sine A cos B plus cos A sine B. Cos of A plus B is cos minus sine. Cos A cos B minus sine A sine B. So here's what I want first, and then post your answer on the comments so I can check to see what you're doing. And this one I'm going to ask someone other than Kristen to post the answer first. I want you to generate an identity for sine 2 theta. So think about that for a minute. And if you want a hint, 2 theta is the same as theta plus theta. 2 theta is the same as theta plus theta. So go ahead and establish an identity for me and write the answer on the comments. Can I get someone to post on the comments, someone other than Kristen this time? What is sine 2 theta? What is sine theta plus theta? Harley says, I don't understand where I would get a value for 2 theta. We agree that 2 theta is the same as theta plus theta, right? 2x is x plus x. 200 is 100 plus 100. So 2 theta is theta plus theta. So A is theta and B is theta. So we're looking at our identity up here, right? So sine A cos B would be sine A cos B. So sine A cos B plus cos A sine B. Sorry. It's difficult to see. Let me go ahead and write it bigger. So that's sine A cos B plus cos A sine B. Yes, Harley's answer is correct, but can you simplify that, Harley? That's a good guess. Good answer. So I'll continue. A is theta, B is theta. So as Harley said, sine theta cos theta plus cos theta sine theta. Can anyone simplify that for me? If you add those two together, what's the result? Post that on the comments if you see it. Nobody. They're the same. Sine theta cos theta, sine theta cos theta. Just the order is switched. So the answer is 2 sine theta cos theta. I'm not going to ask you to memorize much, but memorize this for calculus. The double angle identity. Sine of 2 theta is 2 sine theta cos theta. So write that down in big letters, put stars around it. You're going to need that in calculus class. That's an important one to have. Now notice where it came from. It came directly from this identity. Sine of A plus B is sine A cos B plus cos A sine B. Now let's go ahead and try to do the same thing for cosine of 2 theta. So I need the identity first. I need cosine of A plus B. Cosine of A plus B is cos minus sine sine. Cos A cos B minus sine A sine B. But I want cos of 2 theta, which is cosine of theta plus theta. So again, A is theta, B is theta. So A is theta, cos theta, B is theta, cos theta. So I get cos theta minus sine A, sine of theta, sine of theta. And isn't this interesting? So cosine of 2 theta is cos theta minus sine theta, which we can rewrite as cos of 2 theta is cos squared theta minus sine squared theta. So again, memorize this. But there's more identities than that, because what do you know? Our favorite identity of all that we talked about on our video lecture on Monday is the Pythagorean identity. Cos squared theta plus sine squared theta is 1. So I could rewrite cos squared theta as 1 minus sine squared theta. And you will see that that'll give me a new identity. So I started with this identity. I started with cos 2 theta is cos squared theta minus sine squared theta. If I replace cos squared theta with 1 minus sine squared theta, I get cos 2 theta, replace cos squared theta with 1 minus sine squared theta. I get 1 minus 2 sine squared theta. So that's another identity that I can create. But I still have another one. If I solve for sine squared theta up here, subtract cos squared from both sides. Sine squared theta is 1 minus cos squared theta. If I replace sine squared with 1 minus cos squared, what are we going to get? So here's the identity I want you to memorize. This is the one to memorize for calculus. Cos 2 theta is cos squared theta minus sine squared theta, which looks a lot like the Pythagorean identity, just a minus instead of a plus. If I replace sine squared theta with 1 minus cos squared theta, I get cos 2 theta is cos squared theta minus 1 minus cos squared theta. What is that going to give me? Cos 2 theta. Cos squared minus negative cos squared. So let's distribute this. Cos squared theta, change that to plus, and then change the sign. Cos 2 theta is cos squared plus cos squared is 2 cos squared theta minus 1. Again, I don't really expect you to memorize this one. I don't really expect you to memorize this one. But I absolutely expect you to memorize this one. Because it comes up all of the time in our calculus course. So let's go ahead and use this information to answer a question or two. And pi over 2 is less than theta is less than pi. So what do I want to find? First off, I want to find cos theta. Question A, what is cos theta? Well, what do we need to know? Well, there's a couple things. We are more than pi over 2 and we are less than pi, so that puts me in quadrant 2. In quadrant 2, cosine of theta is negative, so I know that. Cosine of theta is negative. What else do I know? Well, I have my absolute favorite identity of all, which is cos squared theta plus sine squared theta is 1. Harley has an answer already. Nice. Let's see if it's right. Cos squared theta plus sine squared theta is 1. I know sine theta is 3/5. Remember what this really means. This really means cosine of theta squared plus sine of theta squared is 1. Sine of theta is 3/5. So cos of theta squared plus 3/5 squared is 1. So I get cosine of theta squared plus 9/25 is 1. And now we have to subtract cos of theta squared is 1 minus 9/25. 25 minus 9, 16/25. So cos of theta, I know it's negative, so it's minus the square root of 16/25. So cos of theta is minus 4/5, which is what Harley says. So we'll give Harley a big smiley face. But that's not the real question that I wanted to ask. Okay, so this is what I know. I know sine of theta is 3/5 now, and I have cos of theta is negative 4/5. I have that information. I want to use that to find sine of 2 theta and cos of 2 theta. So let's look at that. So this is what I have. I have sine of theta is 3/5. And I have cos of theta is negative 4/5. I want to find out what is sine of 2 theta. And I want to find out what is cos of 2 theta using our double angle identities. Well, sine of 2 theta is 2 sine theta cos theta. That's one I want you to memorize. Sine of 2 theta is 2 sine theta cos theta. So we can plug all this stuff in. 2 sine theta is 3/5. Cos of theta is negative 4/5. 6 times negative 4, negative 24. 25th. So the sine of 2 theta is negative 24/25. How about the cosine of 2 theta? Which one do I want you to memorize? The one that looks like the Pythagorean identity, cos squared theta minus sine squared theta. What does that really mean? Is negative 4/5. So I get negative 4/5 squared minus sine of theta is 3/5 squared. So negative 4/5 times negative 4/5, 16/25 minus 3/5 times 3/5, 9/25, which gives me 7/25. So that's cos of 2 theta. So let me ask you this question, and I'll have you post your answer on the comment page. 2 theta is in which quadrant? 1, 2, 3, or 4? 2 theta is in which quadrant? See what you can do. Harley's writing cos of 2 theta. Cos of 2 theta is 7/25. Sine of 2 theta is negative 24/25. 2 theta is an angle, correct? I want to know which quadrant is 2 theta in. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Harley says quadrant 4. Do we believe her? Anybody else want to give a guess? Sine is negative. Sine of 2 theta is negative. Where is sine negative? Sine is negative here and here. Cosine is positive. Where is cosine positive? Here and here. Which quadrants did both of them occur? Right here. Harley is correct. That is quadrant 4. Very good. All right, well, we're closing, coming in on our 50-minute mark, which I think is about as long as these can go and still be functional. Let me just go ahead and remind you of some things I'd like you to work on. Number 1, make sure I get the quiz. I will extend the deadline to before 5 p.m. Friday. Number 2, I want you to work on my lab. Number 3, at some point I will send another quiz. Please send that to me. Please send before our class on Monday. I'm not sure if we'll do a live class or I'll just send you videos. We may do one more live class. The next section, which is going to be right triangle trigonometry, sine is opposite over hypotenuse kind of stuff. I don't think you need a live lecture for that. The recorded lecture should be fine. But this proving trig identity stuff, I think it was important for you to watch me in real time to see how that works. So we'll see. We'll see how things go. So yeah, I'm thinking maybe I'll do one more live class on Monday, and then we'll probably go to recorded ones beyond that for a little while. But we'll see how it goes. Okay, thank you, friends. I enjoyed the time, and we'll do this again on Monday. Get your quizzes in if I don't have them yet. Ciao.